Today we're going to continue talking about sequences, but we're going to focus on what are called arithmetic sequences. So a sequence is arithmetic. It looks a lot like the word arithmetic, and it has the same roots for sure, but we pronounce this arithmetic. This is the adjective form of the noun arithmetic. So a sequence is arithmetic if and only if. So I want to point that out. This big IFF means if and only if, so it works both ways. So sequence is arithmetic if and only if the difference between consecutive terms is constant. So if the difference between every term stays the same, then it is an arithmetic sequence. So meaning if we add or subtract the same amount every time. We will call that common difference D. So if I'm looking at two different sequences here and I want to know whether or not they are arithmetic, I need to look and see what it is that we are adding or subtracting each time. So from -9 to -2, that's adding 7. Can we do that again? Well, if I add 7 to -2, yeah, we get 5. From 5 to 12, that's 7. From 12 to 19, that's 7. So yes, and the common difference is 7. Over here, we're subtracting, that's okay. 23 minus 15, that's a subtraction of 8, right? Well, 15 to 9 is only 6. And 9 to 5 is only 4. And 5 to 3 is only 2. So this is no. There is no common difference between terms. It's a different type of sequence. It's just not arithmetic. Okay, I'll go ahead and pause the video, take like 45 seconds, and determine whether or not these are arithmetic. If they are, I want to know what the common difference is. If they are not, well, then that'll be self-explanatory. So pause and go, and then come back. All right, here we go. From 2 to 5, we're adding 3. From 5 to 8, we're adding 3. 8 to 11, 11 to 14. So yes, the common difference is 3. Over here, we're subtracting. 15 to 9, let's see, that's what, 6? And then from 9 to 3 is 6, and 3 to -3 is 6. And so this is also yes, even though we're subtracting, because our common difference is -6. Here we are subtracting 4, and then subtracting 2, and subtracting 1. So this is a no, because we don't have a common difference. Now you might be able to see the pattern, right? We're dividing each of these by 2 every time. 8 divided by 2, 4 divided by 2, 2 divided by 2. So there is a pattern, but that is a different kind of sequence. This would be what's called a geometric sequence. We'll talk more about that later. But today we're just focusing on arithmetic, meaning we have to add or subtract something, and that's not what's happening here. Because that difference changes, it's not an arithmetic sequence. So to write a rule for an arithmetic sequence is not too hard. The nth term of an arithmetic sequence, when the first term is a sub 1, the common difference is d. Here's the rule. So the nth term is equal to the first term plus the index minus 1 times d. So for example, if we have a first term of 3 and a difference of 2, the nth term is the first term, 3, plus n minus 1. N is going to stay our variable in this case, and then multiply by 2. And then we're going to simplify that. So a sub n is equal to 2n. I got to distribute here, right? So 2n minus 2, but I have that minus 2, and I get to add 3, so it's just plus 1. So we can write it as a linear function. So arithmetic sequences are going to be linear functions. So we're going to write a rule for each of these and then find a sub 15. So we have to find the common difference. What am I adding? Well, 3 to 8 is a difference of 5. Let's make sure that works all the way through. 8 to 13, that's 5, and 13 to 18 is 5. So a sub n is equal to a first term plus n minus 1 times the common difference, so 5. So that's 3 plus 5n minus 5. So 5n minus 2. There's our rule. Then I want a sub 15. So a sub 15 is 5 times 15 minus 2. Well, that's 5 times 15 is 25, and 50, so 75 minus 2. So a sub 15 is 73. So I'm saying a sub a lot, and that just means that's how we read this when we have a little number below. It's called subscript, and it's just a way of saying the 15th term of sequence A. Sometimes people might write it like function notation instead, and that would be okay also. But since the book uses sequence notation, I'm going to try and use that also. Okay, so over here, let's find our difference. 55 to 47. We're subtracting, obviously. That's going to be 8, it looks like. And then 47 to 9 is also 8. And 39 to 31, also 8. So we're in good shape there. So a sub n is going to be the first term plus n minus 1 times a common difference. Common difference is negative this time. That's super important because we want to make sure that we are subtracting that difference, not adding it. So that's going to be 55 minus 8n plus 8. So 55 plus 8 is 63 minus 8n. So a sub n is negative 8n plus 63. If you think back to linear equations, that makes perfect sense. If I'm going down by 8 every time, that's like a slope of negative 8, a y-intercept or starting value of 63. A sub 15 would be negative 8 times 15 plus 63. So that's going to be negative 80 plus 40 is negative 120. So I'm at negative 120 plus 63. Should be what? Negative 57? Yeah. So a sub 15, the 15th term of sequence A, is negative 57. Here's one for you to do on your own, so go ahead and pause this until you finish and then hit play again. Okay, we want to rule. So I'm going to skip a little bit here and say a sub n is equal to the first term plus n minus 1 times the difference. So looks like I'm adding 4, adding 4, adding 4. That's going to work. So my common difference is 4. So a sub n is equal to 7 plus 4n minus 4. So a sub n, my general rule, is 4n plus 3. I want a sub 15. I'll plug in 15. 4. We switched rules here. 4 times 15 plus 3. Well, that's 60 plus 3. A sub 15 is 63. Okay, so not too bad. You're definitely going to want to have this rule written down. So I'm going to come back here. Make sure you pause this real quick and get this rule written down because this is going to be super important as we go through this. Okay. One term of an arithmetic sequence is a sub 19 equals negative 45. So I know that the 19th term of this sequence is 45. Negative 45. The common difference is negative 3. I want to rule for the nth term. So let's just start with the general rule. A sub n equals a sub 1 plus n minus 1 times the common difference, right? So let's plug in what we know. I know that the nth term, in this case the 19th term, is negative 45. I do not know what a sub 1 is. This is the 19th term, so that's my n, and the common difference is negative 3. So I just need to solve for the first term. Then I can go back and write the rule for the whole thing. So 19 minus 1 is 18. I'm going to multiply that by negative 3. So I'm going to have negative 45 equals a sub 1 plus negative 54, or minus 54. So I'm going to add 54 to both sides. So 9 will be my first term, right? Because these will cancel. So my rule, a sub n, is equal to my first term, 9, plus n minus 1 times the common difference of negative 3. So a sub n is equal to 9 plus, or minus, I should say, negative 3n plus 3. So my rule is negative 3n. We're going down by 3, so that's the slope, plus 12. Then we want to find graph the first 6 terms. So really, if you just think about this, this is just a line with a y-intercept at 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, the 0 term would be like 12 because the first term would be 9. So 1, 2, 3, I'm going to go down by 3 again, and then down by 3 again, and down by 3 again. So really, it's just got a slope of -3, and we're coming down like this. It's a terrible graph, but hopefully you get the idea. Whoops. Oh, there's a much better graph, right? So we just plot those initial terms. 1, 2, 3, 4, 5, 6. Different question. What is the sum of the numbers of 1 through 100? So if you were going to add up the numbers 1 to 100, what would the sum be? Not necessarily an easy thing, right? Unless you remember the rule from yesterday, but let's pretend we don't. This is a famous question that was posed to somebody named Karl Friedrich Gauss. He grew up to be a famous mathematician in the 1700s. When he was in school, his teacher was tired of him constantly asking questions. He was always wanting to know more. He was always ahead of the other students. And so he was always asking a lot of questions. So his teacher told him to add the numbers 1 to 100. It was just a useless task. It was just intended to keep him busy so the other students could get more attention because he was bored and wanted to do more. And so this was a way of just keeping him busy so that the teacher could work with other students. He answered the question in less than 2 minutes, and he was in elementary school. What specific age he is a little bit up for discussion. Some people have some different thoughts depending on which writings you're reading. But it's well agreed he was in elementary school. So this kid is like under 10. And somebody asked him to add 1 to 100, and he did it in under 2 minutes. And here's how. Yeah, so what he did, instead of adding them up, because obviously there's no calculators, right? He's doing this strictly by hand. What he did was say, well, if I add up 1 and 100, right, because I've got 1 over here and 100 over here. If I add up those two, I get 101. Then there's 2 and 99. If I add those up, I get 101. If I multiply or add 3 and 98, hey, what do you know? That's 101. So he just realized that no matter how many of these pairs you make, they always add up to 101. Well, if there's 100 numbers and I'm putting them into pairs, how many pairs are we going to have? There should be 50 pairs, and each pair should be 101. So you multiply 101 times 50, and we end up with 5,050. So if you were to add up the numbers 1 to 100, this is the total. He did it that quickly without being taught that, just by figuring it out. And from that is how we are able to add huge sums of arithmetic series. So this top part is just showing that same pattern. If you add these up in pairs, you can get a shortcut. So here's the part we care about. Here's the rule. The sum of the first n terms, so this doesn't go forever. The series could be infinite, but we're only adding certain terms. If you take the first term and the last term, or the nth term that you're talking about, you find the average and you multiply by the number of terms, then that'll be your sum. Okay, so let's jump to one. Find the sum of the series 3i plus 7 from 1 to 20. Well, I don't care about all those terms in the middle. I want the first term. So if I plug in a 1, 3 plus 7, the first term is a 10. The last term, 20 times 3 is 60, plus 7, 67. I'm going to take that average and multiply it by the number of terms that there are. Right, so 10 plus 67, that is 77 over 2 times 20, or cancel out the 2's there. That's 77 times 10, which is 770. I mean, that's not an easy thing to do. I just took this pattern, asked you to plug in 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 20, and then add them. But using that formula, we can do that by hand in less than 30 seconds. Okay, not super crazy difficult. Here's another version of that. You're making a house of cards, similar to this one. Write a rule for the number of cards in the nth row if the top row is row 1. So we're saying this is the first row, and we're going to count all 3 of these cards. So 1, 2, 3. We'll say that is the top row. Okay. So how many cards would you need to make a house that has 12 rows? I'm going to give you a couple minutes with that. Go ahead and pause this and then come back. Okay, so if we think about this, first row has 3. Second row is going to have 3 here and 3 here. So first row's got 3. Second row's going to have 6. The third row has 3 in this triangle, 3 in this triangle, right? If you look at the little triangles formed, there's one there, there's one here, and there's one here. Each of those has 3 for a total of 9. So you can see that our series is going up by 9. So our first row has 1, and the second row has 6, and the third row has 9. So if we were to write our rule, that would be a sub n equals 3 plus n minus 1 times, what are we going up by every time? 3. So my rule is 3n, and that's just it, right? Because I have minus 3 from this guy and a plus 3. Those are going to cancel. Really, what row? First row times 3. Second row times 3. Third row times 3. So I'm trying to find the sum of 3i from when I is a 1 until it is 12. So let's just find the first term and the last term. Remember, our rule is to find the average of each term, of the first and the last, and then multiply by the number of rows or pairs. So I plug in a 1. Well, my first term's a 3. The last term will be 12 rows times 3 will be 36. I'm going to take the average of that and multiply by the number of rows that I have. We're going back to this formula right here. So if you didn't write that down, I'll give you a second right now. Pause this. This is for the sum of the first n terms of an arithmetic series. Put that in your notes if you don't have it right now. Pause the video and put that in your notes. Okay, so that's what I'm using right here, right, is that formula. So 3 plus 36 is 39, so I have 12 times 39 over 2. Well, what's 12 divided by 2 is 6, so I have 6 times 39. You could do that in your head if you want. 39 times 6 should be 234. You're going to need 234 cards to make a house with 12 rows. If you're interested, that's 4.5 decks. Okay, so keys from today are those two formulas: the formula for the sum of the first n terms, and the formula for writing the rules. So if you need, scroll back in this video and find those formulas. Otherwise, go ahead and tackle the homework. Good luck.